Largage du mât KZM. À tous de DDO, attention pour la séquence finale lanceur. Top H0 moins 20 secondes. Largage du mât VKM. Allumage du triétage. Attention. Top 9, 8, 7, 6, 5, 4, 3, 2, 1. Top, décollage. Poussée nominale des premiers et deuxième étages du lanceur. Les moteurs des premiers et deuxième étages fonctionnent normalement. Bonne stabilisation du lanceur. Le vol est nominal.
Beautiful pictures there in the clear blue sky above the Guyana Space Center, over the Amazon rainforest. Soyuz blazing a trail. Range Operations Manager is telling us that everything is going according to plan, everything's nominal.
La propulsion du premier et deuxième étage est nominale.
The propulsion of the first stage is nominal. Our altitude, bottom left, 36 kilometers above Earth. Our speed coming up to 2 kilometers per second. And you can see the boosters being jettisoned. See how they twist and turn. All part of the plan. We have confirmation there of separation, and we saw them. We don't need them anymore. The boosters can fall away. We're shedding weight. We're burning the core stage now. The Block A burns for nearly 5 minutes. Picking up in speed there on the right-hand side and climbing into space. Right now we are 78 kilometers high and getting closer to what we call the Kármán line. That's the border with space. It's named after the Hungarian-American aerospace engineer Theodor von Kármán, who died in 1963. And it's where the air becomes so thin that we can no longer support vehicles with wings, and we have to use rocket science to stay up. Look at the front of the vehicle there. That's the fairing, the nose, and in there are the satellites. It's protecting them from the rigors of the launch. Notably the acoustic vibrations. You can just imagine how loud it is. Everything's going according to plan. And also friction, because as we fly through the dense part of the atmosphere, it causes the outside of the fairing to heat up. But as we get closer to the Kármán line, the air becomes so thin that we hardly have any friction and we don't need the fairing anymore. So this is the scheduled moment where we lose it. It gets jettisoned, and we can see our satellites for the first time. Attached there on the front, and he's confirmed that the fairing has been jettisoned. Attached there at the front, the left-hand side, some great images there from cameras on board a previous launch.
Le fonctionnement du moteur du bloc A est nominal.
He's telling us that the functioning of the Block A motor is going normally. So the 4 O3b spacecraft, lovingly built by the men and women at Thales Arianespace, who are experts at this kind of thing. And if you look in the middle of the rocket, you can see a sort of latticework structure by the orange section. That is because Soyuz uses what's called a hot stage technique when it separates the stages, the second and third stage. The third stage engine switches on before the second stage switches off, and he's confirmed there that separation. So you can see our tracking stations here. Galileo, that's at the Guyana Space Center. And then Natal, that's on the northeastern coast of Brazil. Then we have Ascension in the middle of the Atlantic. And we're heading across the Atlantic. It takes a little bit of time for information to get from the launcher to us here at the CSG. Those stations send the information back here, but it has to go via Moscow first in order to be validated. So we're seeing all the key moments when they are scheduled to happen, but we get the actual confirmation from the range operations manager just a little later. That's perfectly normal. Good view there of the 4 satellites attached to the dispenser, or the special adapter, which is that cone in the middle. A cone is the wrong word, a tube. And all 4 of them attached in an array, like petals from this angle. It takes Soyuz just under 2.5 hours to deliver the satellites from liftoff.
This mission will comprise several steps, the first of which being the 3-stage Soyuz flight. The action of the boosters, the second stage, and finally the third stage shall position the frigate to an altitude of 200 kilometers after 9 minutes. Then, following 3 frigate boosts, the spacecraft will be put into the separation orbit. The first pair will be separated after 2 hours and the second pair 20 minutes later. In parallel, frigate will perform 2 other boosts in order to join its disposal orbit, where it will end its life. This mission will be visible from our ground tracking stations: Galileo in French Guiana, Natal in Brazil, Ascension in the middle of the Atlantic, Libreville in Gabon, Malindi in Kenya, and South Point in Hawaii.
So those are the tracking stations picking us up as we fly over, and we are scheduled to pick up the signal during that film there in Natal. That's the one in Brazil. You can see it there on the right-hand side. The tracking stations are often known as downrange stations or ground stations. The information that they pick up from the launcher tells us how the flight is progressing in real time, and it allows the experts to work out if things are going according to plan. And it also enables them to make an assessment after the flight and check how things went. It's called telemetry. It comes from the Greek. Tele, of course, means remote, and metron means measure. Everything's going normally. These computer-generated images are a simulation of what the experts have calculated is happening to the launcher and the satellites. The teams plan a very precise schedule of events, which is based on extremely accurate predictions for the flight, and they put all that information into the computer. These images are then a simulation of those predictions. So every movement and every position that you see is a simulation of exactly what's been planned for the flight. He's telling us that everything's going according to plan. You can see there This is the scheduled moment for the third stage to shut down its engine. We're really starting the next phase now of the journey. The upper stage is taking the wheel. It's called Frigate. And it's the intelligent part, the powered stage of the flight.
Du bloc I, séparation de l'étage frégate.
Is over, and that's been confirmed. And Frigate has the rather more subtle job of delivering the satellites to a specific orbit and separating them. You can see on the top right is our trajectory. That's the planned trajectory, and the white cross is the actual position of the launch vehicle. Right now, Frigate's getting ready to switch its engine on for the first ignition. There it goes. This is the scheduled moment. It's going to burn for just under 4 minutes. Frigate is that gold structure. You could see it back there. On the right of the screen, you can see it is made up of 6 spherical tanks, which are organized in a circle. 4 of those are...
Tous les systèmes bord fonctionnent nominalement.
He's telling everything's working fine on board. 4 of those are for propellants and 2 for avionics. That's the sort of thing you find in the cockpit of a plane. Flight control systems, navigation, communications, that kind of thing. And Frigate was originally designed as an interplanetary probe. It was adapted to fly on board Soyuz, and it can switch its engine on and off up to 20 times. So it can take its passengers pretty well anywhere they need to go. And that makes Soyuz ideal for launching constellations like today. And of course, with all 3 rockets here at the Guyana Space Center, Arianespace can launch any satellite to any orbit. And this was 12 minutes ago. Superb liftoff there. From the Soyuz launch zone near Sina Marie. Today, Frigate is scheduled to perform 3 burns before separating the satellites. This is the first one. Takes us to a transfer orbit. Then we have a coast phase. The third burn will take us to the separation orbit. That's where we'll start releasing the satellites. On the right-hand side of the screen, you can see that whereas before we were using all our power to get away from Earth, our curve has platted out a bit. He's telling us that we're picking up the signal there at the Ascension Island tracking station, which is a volcanic outcrop in the middle of the Atlantic. Used to be a stopover during the early days of commercial airlines. And NASA had a communications dish there during the space race, I believe, in the mid-1900s. And I think that it was used to track the Apollos. So that means we are powering our way across the pond, across the Atlantic, towards the west coast of Africa. So, yes, on the top right-hand side of the screen, we were using our power to really pull ourselves away from gravity. Now we're using it to really pick up speed, and so that we can climb higher and higher later in the flight. You can see the bottom right of the screen, our speed is above 7 kilometers per second. This is our scheduled time for the frigate upper stage to switch its engine off. The onboard computer sends the command when it knows that the upper stage is in the right orientation, at the right speed, at the right altitude, that sort of thing. Frigate upper stage is getting ready to switch its engine on now for the second pre-burn phase. Basically, it puts its foot on the accelerator and gives a burst of thrust to push the fluids back into the tanks. And here we have the scheduled ignition, the second ignition, which lasts for 8.5 minutes, roughly. I have to say, O3b is a very pioneering project. As I said earlier, its aim is to provide affordable, high-speed internet from space to billions of people who are presently unconnected. And I think it's fair to say that we often take broadband for granted. But actually, it is a privilege. And now that privilege is extending around the equatorial part of the globe, thanks to the O3b satellites. And of course, Arianespace is delighted to play its part in helping to reduce that digital divide. It's launching all of the satellites in the constellation. So how does O3b do it? The satellites, how do they do it? Well, a bit of history. O3b came from a big idea originally when the founders were trying to lay cables in Rwanda to connect schools, I believe, to the internet. And they found it very challenging. And they decided it would be better to connect using satellites. However, most telecom satellites are in geostationary orbit. And for anybody who's unfamiliar with this, we have 3 types of orbit. We have low Earth orbit, we have medium Earth orbit, and we have geostationary orbit. And geostationary orbit is 36,000 kilometers above Earth. And anybody who has used a satellite phone will know that it takes a few seconds for the signal to travel 36,000 kilometers into space and back again. And that delay is called latency. So the O3b founders decided to put their satellites closer to Earth, in medium Earth orbit, around 8,000 kilometers. That's about 4 times closer to Earth than the geostationary satellites. And that way they were able to reduce the delay. So that's why the O3b satellites are often thought of as fiber from space, because they give customers that low latency connectivity, which is similar to the kinds of speeds that you get from fiber on Earth. So when the teams decided they wanted to connect all these billions of people,
l'allumage du moteur principal frégate pour le deuxième boost.
Getting ready there to switch the engine on for the next boost. So they decided they needed an industrial partner, and that partner is Thales Alenia Space. The men and women at Thales Alenia Space are very experienced at building constellations. And they drew on that know-how to create innovative technology for O3b. And they too had to think outside the box when they designed the spacecraft. For this latest batch, they've increased the performance. Here is the CEO.
When the first batch of O3b satellites lifted off in 2013, it was a decisive moment. It was the beginning of a new era in space. It opened the way to constellations in medium and low Earth orbit dedicated to high-speed broadband. It opened the way to fiber in the sky. At Thales Alenia Space, we supported O3b's exciting initiative from the very beginning. Now, Here we are 5 years after that first launch, sending this fourth batch into orbit to feed the constellation, making scalability a reality. These 4 new satellites will provide even more capacity and flexibility to O3b's customers. At Thales Arianespace, we are very proud of our outstanding partnership with O3b, and we value the special relationship we have developed over the years. Today is important for all of us, and especially for SES Networks, who are continually expanding their business. We are fully committed to helping make this constellation a great success. Our congratulations to all the teams, and our warmest thanks to SES for the trust in Thales Arianespace.
And after today, Arianespace will have launched 154 satellites built by Thales Arianespace, and there are 11 others in the order book. During that film, we were scheduled to pick up the signal at the tracking station in Malindi, in Kenya, on the east coast of Africa. We had a few issues over the weather, so the teams chose to take the option offered by Soyuz to launch 33 minutes later exactly than the scheduled launch time, and that gave them the flexibility that they needed, and we had a perfect liftoff.
Début de la manœuvre d'orientation du frégate pour le 3e boost.
We were very lucky because we had blue skies over the Amazonian rainforest, and we were able to see the boosters separating, and look how they twist as they fall away. We then had the fairing jettisoned, and we switched on the engine of the 2nd and 3rd stages, and then frigate, the upper stage, took the wheel and switched its engine on for the first of its burns. We had a ballistic phase lasting about 8 minutes. Then the frigate upper stage switched its engine on again, and we've just had a ballistic phase now, which is lasting about 1 hour and 20, and coming to the end of that. The job of the frigate upper stage is to deliver the satellites to their injection orbit, where they will release the satellites into space. It needs to put them into a very specific position for their journey, a specific orientation. And to do that, it needs to start accelerating again, and that's why we'll need the engine back on for the final push. A reminder, we get our confirmations a little after the main events have happened. That's because it takes time for the information to get from the launcher to the Guyana Space Center. For the Soyuz mission, it goes via Moscow for validation. This is the scheduled moment now for the frigate upper stage to switch its engine on. It's going to burn for just under 5 minutes. And as I said, this is the final push to orbit now before we can start separating our satellites. We're being tracked right now by the tracking station in South Point in Hawaii. It's scheduled to oversee the separation, and I can just imagine that the concentration levels there are very high as we get closer now. Arianespace engages in long-term partnerships with its customers. With these 4 O3b satellites, they will have launched 57 spacecraft for SES. And in terms of the O3b constellation, some teams have been working alongside each other for months. There we go, we have the confirmation there of the third boost.
Le moteur fonctionne nominalement.
He's telling us that the motors are functioning normally. You can imagine that there are some good friendships during these campaigns.
So we are here today with Tim Gore, the O3b Satellites Program Manager. And what about the launch campaign? How did it work?
This launch campaign is more complex than a typical single satellite launch campaign due to the need to process 4 spacecraft in order to get ready to start combined operations, which means we were simultaneously shipping satellites from Rome, testing satellites in S1, and fueling satellites in S3. This is our 4th launch campaign with Thales and Arianespace for launching 4 satellites at a time on the Soyuz launch vehicle. So knowing the constraints and processes really help things run smoother. Plus, we have also successfully incorporated lessons learned from our previous launch campaigns. But the most important factor was the open and cooperative way in which all the teams worked together to organize and support the activities. We really appreciate all the efforts that Thales, Arianespace, and their Russian partners, Kinesis, have put forth, working long hours and weekends to make this launch on this date.
And finally, can you tell us a few words about what is going to happen after the separation?
After the spacecraft separate from the dispenser, the spacecraft computer boots up, configures the satellite, and deploys the solar arrays. After that, it is time to boost the satellite into its final orbit, which require 4 orbit-raising thruster firings by the satellite. Once on station in the final orbit, the satellite undergoes its post-launch health checks, and the satellite is then commissioned to start service.
Okay, many thanks, Tim.
So there you have some information about what's going to happen. Everything going normally, we're being told. Looking at the teams here, there's Tim in the Mission Control Center. Looking at our curve on the top right-hand side of the screen, our trajectory, you can see that we're really plateauing out now in terms of our altitude. And you can see that we have, just underneath the curve, you can see our flight path there. We lifted off from the Guyana Space Center, which is on the northeastern coast of South America. We headed out east across the Atlantic. We crossed Africa, and then we headed out across the Indian Ocean, across Indonesia, over to the Pacific, across the Pacific, and we're now being tracked by the tracking station at South Point in Hawaii. Our altitude's fixed at the bottom left-hand side of the screen at 7,838 kilometers. And our speed there increasing slightly, 4 kilometers and 23. And of course our distance is increasing. We've traveled nearly 13,000 kilometers in a straight line, if you were to do a straight line across the planet. And this is the scheduled moment now for ignition, cut-off rather, of the frigate upper stage. Switching off its engine, it's orientating the satellites and starting the preparation process here, the orientation maneuvers. While frigate flies over the tracking stations, it downloads information to those stations, and then that gets sent back here to the Guiana Space Center, of course going by Moscow. And while frigate was coasting over the Pacific, it stored all its information about the flight in its memory, and it downloaded it to the people at the South Point downrange station in Hawaii when it checked in there. And South Point then sent that information to these teams here. These are the CVI teams, or the immediate visual control teams. They receive the telemetry information and they analyze it.
Confirmation de l'extinction du moteur frégate.
He's confirming there that the frigate upper stage has switched off its engine. So they analyze the information to see how the flight's progressing in real time, and then they pass that on to the range operations manager in the mission control center, who can then call out those confirmations. And as I mentioned earlier in the flight, they also analyze the information after the event, and that allows them to check how the flight progressed and also to make any modifications. Just a reminder here on the right-hand side of the screen, those computer-generated images that we're looking at are a simulation of what's happening in space. The teams put their predictions and all their data and all the information into the computer, and then it generates these images. So it gives us the opportunity of actually visualizing what's happening up there. And for anybody who's just joining us, we're looking here at the frigate upper stage, the gold structure, with its 6 spherical tanks. That's on the left, and attached to it are our 4 O3b satellites, all folded up. This is the scheduled separation time for the first 2 satellites, numbers 14 and 16. They're separated 2 by 2, diametrically opposed, and they're stabilized on 3 axes. You can see them moving away there on the right-hand side of the screen. The second 2 are still attached, of course, so they're continuing their journey, making their way to their injection point. It's going to be 20 minutes before we separate them. We drop them off slightly underneath their orbit, and they have to climb on their own to their final position in space.
Fin des manœuvres d'orientation en vue de la séparation des 2 derniers satellites.
So we're orientating the satellites now. The upper stage is going through a very carefully planned set of maneuvers in order to put the satellites in exactly the right orientation in order for them to be able to continue on that journey on their own. The other satellites will have started deploying their solar panels after 4 minutes and 30 seconds after separation. 6 minutes later, they were scheduled to rotate their panels by 180 degrees and then start pointing towards the sun, which allows them to charge their batteries and power up the satellites. And we still have our next 2 attached here. You can see to the special dispenser, the tube in the middle there. Everybody focused very hard at this point before the scheduled separation time. Looking here at the frigate upper stage, the gold structure, the circular structure, with the special dispenser and 2 more O3b satellites attached, there with their solar panels. And this is the scheduled time for them to separate and move away from that dispenser. And we wait for the confirmation of that separation from the range operations manager. Looking here at the view from the hillside just near the Jupiter control room. Here are the SES teams. The batteries in those solar panels are lithium, just like in your phone. And it's their longevity that gives the spacecraft a long lease of life.
Confirmation de la séparation de la dernière paire de satellites O3b, FM13 et OFM16.
So we have confirmation there from the range operations manager that the next 2 satellites have been separated. Now we need to wait to hear from SES to check that we have received the signal from the next 2 satellites, and that could take a few minutes.